Hello guys, welcome back to my channel Memo African Motives, as we shall be working on engineering science N3. So in this case we shall be working on moments. So we are given the question that is on moments that we shall be focusing on. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So the first question is to define the moment of a force. Okay, that is the first question that we have. So these definitions, guys, they do repeat now and again. So that is the proper definition that we can use for a moment of a force, which is the force multiplied by the perpendicular distance from the fulcrum to the line of action of the force. That is actually the definition that you can use in this case. Okay, then let's quickly rush on to the question that we are given there on 2.2. Study the loaded beam ABCDE of a uniform cross-section in Fig 1 below and answer the questions. Okay, so you're asked to actually study what is happening there. Then calculate the reaction and the supports and test your answers. Okay, so the first thing, guys, when you are actually working with moments, you are given a beam like that, you can actually redraw your diagram because of the laws that you are given. Take note here, we have a distributed load of 8 kilonewton per meter for 5 meters. So which means we can just have a sketch of the diagram, how it is going to look like after being simplified. Okay, so the first part here is not going to be affected. It's going to remain as it is. It's facing downwards, and you have a 2 meters in this case. So this one is going to remain as it is at A. So take note here, there is a force of 10 kilonewtons, okay, which is at A. Just write as this as it is. Then we have 2 meters in this case. Okay, so this is fine. Then we have this part at B now, which is, this is now a support, so you have to indicate with an arrow here at B. Okay, that's why I'm having a major emphasis, because this is a distributed load of 8 kilonewton per meter for 5 meters. So which means you're going to multiply 5 times 8. This is 8 by 5, which is 40. So it's going to be 40. So we are going to divide this 40 into 2 like this. Okay, let me write this. This is 40 here, 40 kilonewton. Then you divide it into 2 because this is distributed for 5 meters. Okay, so you divide this 5 by 2. So if you divide properly, you're going to obtain 2,5. So it's going to be distributed or to be shared in 2 ways. We are going to be shared by 2,5 and another 2,5 like this. So this is what is important, but taking note that the actual distance between these 2 points is not going to change. It's going to remain as 5, but we have divided according to this force that you are given. So is the, when you are given force per meter like this, you are given 8 kilonewton per meter, you multiply by the number of meters, then you divide into 2. Okay, then we have the reaction, which is the support here at what, at C. So this is the support that we have at point C. Okay, then from C we move on to D, where there is a force of 12 kilonewton facing downwards with 3. So this one, there's nothing that is going to change. It's going to remain as it is, and there's a difference of 3 meters in this case, which is 12 kilonewton. Nothing is going to change here. This is at D. Okay, we have E, which is the same, 2 meters and 9 kilonewton. Nothing is going to change again here. Just write as it is. This is at point E. This is at E, and there's a distance between of 2 meters, something like this. Okay, so now with this diagram, you can actually simplify further, because the question is to calculate the reaction and the supports, okay, and test your answer. So let's start with the first support here, because the supports, we are not even told which are the supports there. So this is the support, this one that are facing upwards, which is B and C. Okay, so we are going to take moments about B. Let's start with the B, the one that is facing upward, that is B here, and C. So about B, take note, guys, you are working with this. This is the B that you are here referring this part here. So what you are going to do is to take the direction from C here. We have these forces which are on the right side of B and this one which is on the left side of B. So this force which is on the left side of B is going to correspond together with this point C. So it's C back to B. What is the distance of C to D? Because remember, it's moment, which is the force times the distance. So it's the force here that is going to be at C times the distance of what? Of 5. There's a difference of 5 meters in this case. So you're going to multiply C by 5. Okay, so it's going to be C multiplied by 5 plus the one that corresponds on the other side here, which is on the left side, because this is on the negative and also on the negative here. So it's 10 times 2. On this side we have 10 and 2. Okay, so 10 back to 2 is going to be 10 multiplied by 2, which is equivalent to, you take all the other forces which are on the right side of B, all the forces which are on the right side of B, which means we are referring to these forces here on the right side of what? Of B. So it's 40 times the distance back to B, 40, there's a difference of 2,5, so it's 40 times 2,5, that is the difference there. So it's 40 times 2,5 plus, we move on to another one. We have 12 here back to B. So 12 here, as you can take note, there's a difference of 3 and also 5 here. So it's 5 plus 3, which is 8. So it's going to be 12 times 8. So you're going to have 12 multiplied by 8. Okay, we move on to another one. We are now at 9. So it's 9 times this distance, which is remember this was 8 plus 2, which is 10. So we have a distance of 10. So it's going to be 9 by 10 like this. Okay, so these are the forces which are the moments that you're going to take. So remember, we have moments clockwise which are equal to the anti-clockwise moment. Will be equal to the clockwise moment, something like that. So this is something that you just have, but you can actually take this according to the directions, the way that I was taking. So we have 5 times C, which is a 5C, plus you multiply 10 by 2, that is 20, which is going to be, you multiply these together, then you simplify and obtain one answer there. So which means we are going to have something like, let's see, if we simplify this, it's going to be 40 times 2,5. So this is, we can just open a bracket there. So let's just open the bracket. That's 40 times 2,5 plus, open another bracket, that's 12 times 8. 12 times 8 plus, open another bracket, that's 9 times 10. Okay, so you can just simplify these together. You're going to obtain 286. Okay, so this is 286. Okay, so 5C will be equivalent to 20 to this side. We are going to subtract from 286. Let's subtract 20. Okay, we are going to obtain 266. So this is going to be 266. Then to find C, we divide by 5 by 5. So this answer that we have, we divide it by 5, which means we are going to obtain 53,2. Okay, so this is going to be 53,2 kilonewton, like that. Okay, so take note about this part here. We are going to have 53,2 kilonewton, which is when taking the moments which are about what? About B. So take note, the part that we are given is we have to use these supports. So you're going to move on, but now we have to take moments about C, which is the other support that you're given. Okay, so it's just like a vice versa this time about C, which means we have something like this. I want you to see, this is our C here. Okay, so on this side here is going to be B back to C here, this B here back to C. So it's going to be B times the distance between, which is the force at B, times the distance back to C. So it's going to be B times 5, which is 5B. Okay, so we have 5B plus, so take note guys, this part here, B is on the negative region in this path here. So it is going to correspond with the forces on the other side of C, not on this side where B is. It's going to correspond with these forces on the other side. So you add these forces, the moments from these forces to this one of B back to C. So which means we are referring to this 12 and 3. So it's going to be 12 times 3. So that's how you take this. B is the one that you are referring to. So these ones on the other side of B, you are not going to talk about them. They are not the ones that are correspond. B is going to correspond with the other part which is on the other side from the clockwise and anti-clockwise moment. Okay, so it's going to be 12 by 3. So we're going to add this on the other side of C. It's 12 and 3 plus 12 by 3. We have another force again, which is on this side of C, this side. So it's 9, and there's a difference of 3 plus 2, which is 5. So it's 9 by 5. Okay. So there are so many ways of taking this. I don't know the way that is best for you, but that is what you're going to have there. Okay. So we are done with this part of B. We move on to the other side now. This side where B was, we are left with 10 and 40. So it's going to be 10 back to C here because we are referring to C. So 10 back to C is 10. The moment there times the force times the distance, we have 2 and 5. So 2 plus 5, that is 7. So it's 10 times 7 back to C. Okay. So we have 10 times 7 plus, we move on to another one. We still have another one on this side. We have this 40. And there's a difference of 2,5, so it's 40 times 2,5 back to back to C. So it's 40 and 2,5. That's how I actually take these. So like I said, there are so many ways that you can use. If you have another method, let's talk on the comment section. Let me know the areas that we can use to actually determine these. Okay, so simplify these together. That's 12 by 3 plus 9 by 5, okay? 12 by 3 in bracket plus 9 by 5. Something like this. We are going to obtain 81, okay? So just have 81, which is combine those ones on the other side. That is 10 by 7. 10 by 7 plus, this is 40 by 2,5. 40 by 2,5. Okay, you combine these, you're going to obtain 170. Okay, that's 170 in this case. So take this, we are going to remain with 5B transpose 81 to the other side is going to subtract. That's 170 minus 81. We subtract, which is going to be 89. Okay, then we divide by 5, so B is going to be 89 divided by 5, which is 17,8. Okay, sorry, so you're going to obtain 17,8 kilonewtons like this. Okay, so this is what we have on B. So now we are not just given this, we are now given to prove this by this, then and test your answers. So which means you have to test your answers. So how do you test these answers? You're going to use the Newton's third law, which states that the sum of forces which are going upward forces is going to be the sum of downward forces. Okay, so we are going to use this to prove if we are referring to upward forces is going to be equivalent. So you can even use this here, which is equivalent to the downward forces. Okay, so these are the ones which are going upward at B and at C, and these are the ones which are facing downwards. Okay, so at B we obtained 17,8. Remember that at B we obtained 17,8. So for upward force, this is upward, so we have 17,8 plus the one again which is going upward is C. C is going upwards, which is C. We obtained 53,2. This is what we obtained at C, which is 53,2. Okay, so let's replace this 53,2, which is equivalent to the ones that are going downwards, that are facing downwards. These ones that the ones that are facing downwards, we have 10, 40, 12, and 9. So you add them together. 10 plus 40 plus 12 plus 9 like this together. Okay, so let's add these two first. 17,8 plus 53,2, so you just add here plus 53,2, which is 71, which is equivalent, so this is 71 kilonewtons actually, which is equivalent to, we add those forces together, remember we have 10 plus 40, 10 plus 40 plus 12 plus 9, yes, this is going to be 71 like this again, so that's 71 kilonewtons. So as you can see, these are actually equal, so that is the proof that we're actually going to use in this case. Okay, then let's move on to another part. We are now given to draw a shear force diagram using the suitable scale. Show all the main values on the diagram. Okay, normally I always use this presentation here that we have. Remember, we have the B, this one at B is, we obtained 17,8 kilonewtons, and at C we obtained 53,2 kilonewton like this. Okay, so in order for you to have the shear force diagram, guys, this is what you're going to do. I want you to learn this in an easier way. You are going to have something like this. For the scale, you can just write even 1 centimeter to 1 millimeter. Yes, you can just use 1 millimeter to represent 1 kilonewton. Yeah, something like that. You just use a normal scale. Okay, so which means you're just going to use these units as they are. If you maintain this, which means for 10, you're just going to write 10 as it is, 40 as it is. Okay, so a shear force diagram is just indicating the forces according to the way that are given. So this one is going downwards, so which means you are going to represent with a horizontal line. So a horizontal line is there to show that this is equivalent to 0 at this point. So the first point at A there is facing downwards. Remember, this one is facing downwards. So you're going downwards from this point. You have to go downwards 10 units downwards like this. So let's say this is 10 units at this point. So this is at negative 10. Since you are going downwards, this is the horizontal axis where we have a 0 at this point. Then we are now going downwards. So you're now at this point. Okay, then there is a distance from A to B of 2 meters. There's a distance here. So when there's a distance between the points, you just move to the right like this. This is the distance that is between what? A and B. Then from B to C, yes, there's a distance of 5 meters, but take note, there was a distributed load that was there in this case. So this distributed load is going to be represented by a diagonal line like this. Whenever there is a distributed load, you use a diagonal line. Okay, sorry, before that we have to start with B, because we moved from A to B. Then B is going up 17,8 first, going upwards. Okay, so if it is going upwards 17,8, which means it's going to be 17,8 minus 10. Okay, 17,8 minus 10 like this. Okay, which is 7,8. So this is going upwards until 7,8, upwards until 7,8. So you just assume that this is 7,8. It's just an assumption, guys, that this is 7,8. Okay, this is the point B. Okay, then that's where we now move from B to C, where there is a distributed load, which is this one like this. So it's going to be taken from this point. We have 40, so it's going to be minus 40. So it's going to be 7,8 minus 40, because it's going downwards. 7,8 minus 40 like this, which is going to be at minus 32,2. So as you can see, minus 32,2 is actually below this line. It's below this line, so it's going to be something like this. Minus below this line, yes, something like this. As you can see, this point is below this line. So let's say this is our minus 32,2 like this. Okay, that's where we are now at this point C. So at point C, we now moved upwards 53,2. We are now going upwards, so which means going upwards we add. So minus 32,2, we add 53,2. So plus 53,2, we are going to reach 21. So we are going upwards until 21. But as you can see, 21 is positive and it's above 7,8. So you must show that what you are doing, you understand the information. This line is above 7,8 like this, just above. So this is your 21. Okay, then from this 21, which means we are at point D now. At the D, there is a distance between, to point D, there's a distance of 3 meters before you go downwards. So there's a distance, so you're just going to move a certain distance like this. Okay, so let's just say this is the distance. Then you move 12 downwards, because this is facing downwards. As you can see, this arrow is facing downwards, so it's going to be negative 12. So at this 21, you subtract 12, so it's negative 12 like this. Okay, that's negative 12, which is going to be 9. So we are now at 9. So this one is going downwards until 9. Okay, so remember, we are at point what? At point D now. So from D to E, you're going to move 9 units, 2 meters to point E. So any distance you move horizontally like this, this is the distance that you're going to move like this. Then you move 9 units downwards, because this is facing downwards. So as you can see, moving 9 units downwards means this line is going to close this shape like this at this point. So this is going to be, so this point 9. So from this point to this point is what? It's 9. So take note, that is what you're going to have. So which means this part is not necessary. You're just going to use up to this point. So this is what you are referring to as the shear force diagram. So these are the important points which must be indicated on the shear force diagram. These points must be indicated as they are. Those are the most important points which carries marks. It's not about this shape that you're going to obtain, but those points. So take note how you represent when there is a distributed load like I explained here. Please take note here. You just subtract, because it's going downward. So you subtract this 40 that you obtained, the one that you obtained, then it's going to be a diagonal line like this. But from this point, there is no distance that is in between. It's direct, as you can see, is direct to a force of what? Of 53. That is why we had to add 53,2. So it's going to be direct. There is no distance in between, even between these. Just like this, where there was a certain distance between the points, on these ones there is no distance, so you just join like that, straightforward. So that's how you end up with the shear force diagram from the reactions, or from the forces, from the supports that you have calculated. That's how you can end up with this diagram. So guys, not to miss these classes, make sure that you subscribe to my channel, Memo African Motives, and also don't forget to share and like, comment. Let me know the areas that we can actually work on engineering science N3, so that we can do revisions from question papers. So this was actually from the question paper which was written in April 2021. So that's how they ask these questions. So you have to work on more question papers so that you be prepared for the exams which are ahead of time.